Today we are going to talk a little bit about triangles. Now, when you are putting triangles in groups, you can identify them by their sides, either scalene, no sides match, isosceles, two sides match, or equilateral, all three sides match. They are all the same length. Or you can look at the angles, whether they are acute, all three angles are less than 90, right, which means one angle is exactly 90 degrees, the other two are acute, or obtuse, one angle is greater than 90, the other two are always acute. So when we look at sides, we are saying how many of them match. When we are looking at angles, we're saying, are any of them right or obtuse? Now, every single triangle, 2 out of the 3 angles are always acute. You're just trying to see if one is right or if one is obtuse. Now, this material that I'm going to show you can be used many different ways. It's a sorting activity. You could sort these triangles into piles based on their sides, or you could sort them based on their angles. And what's fun about this material is that it is not actually a math material. This Montessori material is grammar because it's all about the adjectives. So let's take this one, for example. I can see that in comparison, it is a smaller, red, right, isosceles triangle. And all those words that I used were adjectives. I can see this one is small, yellow, acute, isosceles triangle. I could compare that to this one, where is it a large, yellow, acute, scalene triangle. All of those words allow me to identify the individual differences between my triangles. So I'm going to go ahead and take this small set of blue, and we are going to fill out what is called the triangles of reality. So I'm going to look at each one and figure out where on my graph they are. This one has an obtuse angle. I can see that it is bigger than 90. Now, in order for that to work, the other two must be very small acute angles. So I can see here that it does appear to have two sides that match. That makes it isosceles, and it has one angle greater than 90. That makes it an obtuse isosceles. Now this one also has an obtuse angle. This one here is greater than 90, but I can see that none of the sides are congruent. None of them are the same length. So it's going to come over here to scalene obtuse. Now this fellow has a nice 90-degree angle. That means it is a right triangle. I can see that it has two of its sides that are congruent, so that makes it a right isosceles triangle. Now this one also has a nice 90-degree angle, but I can see that all three of its sides are different lengths, so that makes it a right scalene triangle. Now this one doesn't appear to have any right angles, and it does, however, kind of appear like they're similar lengths, but they're not exactly the same. So I can tell that all three of its sides are scalene, and it does have all three angles acute less than 90. Now this one, I can see it also has all three angles acute less than 90, but it also has two sides that are the same length. So that makes it acute isosceles. Now this one is an equilateral triangle. It has all three sides equal, and because all three sides are equal, all three angles are equal. And all three angles being equal means the sides are equal. They all match. Every single equilateral triangle, every single angle on every one that has ever existed or will ever exist are all 60 degrees. That means you can't make a right equilateral triangle. it would be too big and it couldn't close. You can't make an obtuse. You wouldn't be able to make it work. The only option for every equilateral triangle that exists is that it must be acute. So when I look at the different kinds of triangles that I could build, I cannot make a right equilateral and I cannot make an obtuse equilateral. They simply don't exist. So these are the triangles of reality. I can have acute equilateral, acute isosceles, right isosceles, obtuse isosceles. I could have acute scalene, right scalene, or obtuse scalene. So those are some of the ways that I can categorize triangles.